Hi guys, this is going to be lab number 5 for team 3. Today in this lab we're going to be using our position time graph and velocity to find the accelerations. So first we're going to be using the glide that we've been using. First we're going to use a theoretical using our angles like the sine, cosine, and tangent. We'll be using from the Pythagorean theorem. And then with those, we'll be calculating our theoretical acceleration. And then after we do that, we will run our own experiment using our position and our position time graphs and finding our velocity to determine the final acceleration over time. And then with that, we will find the acceleration for a low mass, high tilt experiment. Then we'll put more mass on the high tilt, so it'll be a high mass, high tilt experiment. And then with those two tables, we will find the percent errors for each of them. And then afterwards, we're gonna lower the tilt. So then it'll be a low tilt experiment. First we'll do a theoretical one, and then we'll find the one for like a regular low tilt experiment. And then we'll find the percent difference for that and the percent error. And then lastly, we will be calculating our percent difference for our 3 accelerations that we found through our experiments, and we'll compare them to our theoretical and hopefully get them within less than 10% for the extra credit.
Okay, so the materials for today, we're going to be using capstone like usual, and then we have our universal interface, which connects our sensor to the capstone, and then we have our glides, and these are the weights for the glides, and these are the weights for the height, and then we have this ruler to measure the height. Okay. Ready?
Hi guys, welcome to lab 5. This is lab 5 for team 3. Today, for our lab, we were using our glider experiment, but this time, sorry, I'm just gonna pen it here. This time we were able to set it up on a tilt. And so here is just a little bit of background. Basically, first we were looking for our theoretical acceleration of what we thought it was gonna be on an incline plane. So then these are our values that we were able to determine using some measurements of the weights and whatnot. And we were able to use this formula, which we plugged in these values to go ahead and give us our acceleration or theoretical acceleration of 0.294 meters per second squared. So with that, we were able to now start our experiment. And these are the graphs here. This is gonna be for our first experiment acceleration, which was first a low mass and a high tilt. So we found out that our initial velocity is 0.4 meters per second. This was our final velocity. And this is the acceleration overall in the experiment. And this was actually the percent error that we were able to get compared to this acceleration as well. So now we were asked two questions. First, we were asked, are we expecting a different acceleration? And are we expecting a different percent error? My team and I went ahead and said that yes, we expect the acceleration to be higher due to the mass being added to our glide, since this was a low mass and this is now a high mass. And we put that we are not expecting a different percent error, or if we are, it's going to be a slight change, nothing really significant or whatnot. So over here is our experimental acceleration 2, which we were able to do with this table. And so we found that actually our initial velocity, our velocities were actually very close to each other. Maybe not our acceleration, but we were able to determine that the percent error was actually 19% for this one. So we were pretty much, I guess, partially correct. Like we expected the acceleration to be different, which it was. And then the percent error, 4%, it could be massive or not. It's all subjective, but we were expecting it to change, but change slightly, not change by, let's say, like by a factor of 20% for the percent error, thankfully. So yeah, so compared to these values together, we were able to determine that as well. I'm sorry, and then our initial velocity was 0.48 meters per second, 0.55 meters per second. Our acceleration was 0.35 meters per second squared, and then 19% error. Yeah. So then we went ahead and went to our third step of our experiment, which is using a theoretical acceleration, but now on a low tilt. So basically same thing. I'm gonna go ahead and pan it here. So basically same thing, we were able to determine the values of our glide and our weights. And with this, we were able to figure out that it was actually a 0.5% difference, which makes sense because in this one, this was the length, or sorry, this was like the height of the glide. So the hypotenuse stayed the same because the glide, we didn't change the glide. We were only changing the height, or sorry, the height of the glide. So basically all our values were just cut in half. And so we were able to get 0.147 meters per second squared and a 50% difference. And with that, we were able to start our final experimental acceleration, which was basically just going to be our low tilt acceleration, like our just regular low tilt experiment. Yeah. So when we did it, we got these values here. So we determined that our initial velocity was 0.1 meters per second. Our final velocity was 0.06 meters per second. And our experimental acceleration was actually 0.25 meters per second squared, which was actually similar to our one with the low mass and high tilt, surprisingly enough. But so with this, we were able to determine the percent error as well. I know it's a very large margin, but we basically cut the values in half. So Yeah, it's like a very weird number compared to like the rest of them because the experiments were very different, but that's the reason why we were able, or that we had found that our percent error is actually 70. Anywho, so then we're also asked these two questions right here. Which experimental acceleration has the most significant percent error, and which acceleration had the most unexpected value? So here we put that our third experimental acceleration, which was the one we just determined right here, is that it had the most significant percent error in all three of our experiments. And for the second one, we actually put that our third experiment was also our most unexpected value, just because the acceleration was actually very similar to what we got in the previous one when we, like I said, like when we used the low mass and the high tilt. So it was just surprising to me and my team that we were able to determine this value. And then for the extra credit opportunity, we had to get it within the certain percent. We had to get the percent error percentage lower than, I believe it was, or sorry. Yeah, we were able to get a percent error that I believe was like less than or equal to 15%. So with that, we figured out that we were able to use our experimental acceleration number 1 for our extra credit opportunity. So basically, out of all the experiments, thankfully enough that we got this one, which gave us less than 50% error, which this error could have possibly been something human or something with a glide. So thankfully enough, we were able to determine that and get that done. And now for our concluding points, it was fairly simple. The experiment wasn't very difficult whatsoever. So to conclude, me and my team, as a group, we were able to successfully determine our accelerations and percent error difference fairly easily without multiple trials and whatnot. So yeah, thank you guys so much. And here are our credits right here. I'm Alex. I went ahead and did the explanation and the calculations. Sophia went ahead and helped with the setup and recording of our experiments. Sherilyn went ahead and helped with the experimenting and our recordings. Nadine went ahead and also helped with experimenting and with our calculations. And then Ileana helped do our explanations and calculations. Yeah, thank you guys so much.